right, today we're going to be putting together a stealth bomber e-bike from scratch. So here we have the frame. I've got the swing arm in the closet over there. This is the battery pack that we're going to be using. And here are the wiring and electronics that I've made. I have it set up where all of the electronics are placed on one board over here. And I have it such that this board can be placed directly into the frame and bolted in. So that makes it really easy to build this, and you don't really have to custom mount each one of these components. Plus it has a really low profile and everything could be designed and figured out and wired together here. So you kind of just wire this together, pop it into the frame, and you're basically done. So just to go over some of the components here and the way they work, this of course is the fuse. This is a 250 amp fuse for the main high voltage source. So the positive lead from the battery will go through here and then it will come out on this end over here. Then we have a relay. The key switch will be connected to this relay, and then when you turn the key, the relay will activate and it's going to allow high voltage to flow to the DC-DC converter. So this will convert high voltage to 12 volts, and then those 12 volts will be distributed to this fuse box over here. Then all of the accessories like the contactor, the lights, the, what else do I have on there? The USB port and the LCD screen will be connected to this fuse box over here. And of course, this is the bus bar for the ground junction. So all of the grounds will be connected here. So it's a pretty simple system, and it's all controlled using the key switch to turn on this 12 volt DC-DC converter. Then the way I have this set up is that once the key switch is activated, that's going to allow power to flow through here. And the other side of this relay has two extra wires for the high voltage. So this line is going to be for the controller on-off switch, which requires high voltage. It's just a signal line. So when you provide 72 volts to this line, the controller will turn on. And this is to power the LCD screen. So once you have high voltage flowing from here, that's going to provide power to that LCD screen. So that's going to turn on all when you use the key switch. This is the input connector for the key switch. So the key switch will be connected here. And then when you turn that, the whole system will activate. So this goes into the frame just like that. And actually I need to remove this relay so that I can put a screw here and then screw that down. But that goes right in there. Okay, so now we have everything completed and wired together, and we're ready to give this a test run. So just to go over the wiring once more, here is how everything is connected. We have a power supply here that's being converted to 84 volts to simulate a battery. And this is coming into this wiring panel through this connector here. Now on the negative side, it's going directly to the ground junction where all the grounds are connected from the high voltage and the 12 volt system. Then on the positive side, this is coming into the fuse and then across the fuse to the common line on the relay. But notice that when this relay is closed, this common line goes nowhere. This is disconnected. So essentially this entire circuit is not complete. It's nothing. So there's no current flowing this way. So when the key for the relay is off, the positive line is coming in here and going through the key switch and then to the relay. So then when I turn the key, power will flow to the relay. That will turn the relay on and complete the circuit between here and that yellow normally closed wire. So then once current is flowing through the yellow wire, it'll go through this fuse here and then into the input of the 12 volt DC-DC converter. That's grounded to the same ground junction for the input and the output. They're spliced together and attached right here. Then the output from the 12 volt DC-DC converter will flow to the fuse box. Basically, you have 12 volts at the fuse box, and here is where we would connect all of our accessories. So right now I have only the lights connected. So that's just connected here. This is the negative for the lights going directly to the negative side of this connector. And then the positive side for the lights it's going through this key switch, basically, to the positive side of the lights. All right, so now we're ready to test this. There goes the power supply. So then once I turn the key switch, we should see 12 volts. All right, so that's 12 volts coming from the DC-DC converter. Now if I use the switch for the lights, see the lights are turning on. And that's it, that's basically the whole system. So doing it this way is really simple because you don't have to do any wiring in the bike. You just do everything here. Now we can take this, pop it into the frame, connect a high voltage system. Once we do that, all of the wiring in the bike is done. Super simple. Okay, now that I have the wiring bracket in place, we can add the rest of the components. Now I can add the contactor. This is the USB port that I'll be adding. This is going to be a charging port with an Anderson connector. And of course the key switch that will connect there. So let's go ahead and do that. And now you have all of the components in place. So that's the contactor on the bottom. This is the USB port. This is the charger port right here. And of course you have the key switch. So all of those are tucked away in the front of the frame. And then you have all of the electronic components placed here on the bracket. So now all we need to do is connect everything. And I've already prepared the wires here. This is just the different wires for all the different accessories. I forget which is which, but we'll figure it out. This is for the brakes and stuff, the lights, I think. And then these are the high voltage wiring components. So let's place these into the frame, and then we're gonna wrap all of them to make a wiring harness. And then we'll be ready to assemble this bike. All right, here is everything with the high voltage system in place. These are the high voltage wires. They're just running from here. The negative portion of the high voltage line has a split, and that grounds right here to this ground block. So this connector is the one that provides the ground to everything else. Then that continues to run through here. I've got everything kind of bound together with zip ties. So on the negative side, it just runs through, runs up here, and just comes up over here, and this will connect to the controller. Although I'm gonna put these into a conduit, but I'm gonna have other wires there, so I'm waiting for that. Then on the positive side, you have the positive connector, and that's running all the way to the fuse over here. So that connects to the fuse. Then the other side of the fuse, I have that connected to here. It continues over here. And then that line goes directly to the contactor over here. Then the other side of the contactor is this positive line on this side. So pretty simple over there. Then this line also splits for the charger port over here. There are a couple of splits, so the charger port is connected. And then all of these wires are going to be interfacing with the controller. So these wires are running up this side over here, along with a bunch of the other wires. These will be for the brakes, the brake signal on the controller, and the LCD switch. This will be the on-off ports. This will be the on-off switch for the controller. This will be the main high voltage power line for the LCD screen. And by the way, if you're thinking it's pretty small to power the LCD screen, because it's high voltage, the current will be very, very low. So this is fine. Then these two, this will be the ground line for the LCD screen, and this will be the 12 volt input line also for the LCD screen that runs like a lower LED panel. I don't know why it has two voltages, but that's just the way it is. Then over here on this side, this is the connector cluster for all of the lights. So this one is the main headlight power line. This is the switch for the main headlights. Then this is the power line for the tail running light and the tail brake light. And then this is the switch for the brake light. So when you connect the switch here, the brake light here will activate. And these are all wired internally into the connectors so that you can interface with them very simply. And then back there, you see that is the contactor power line, and this will be the on-off switch for the contactor. So everything here should be connected and ready to go. So what we'll do next is connect some of the accessories on the bench, make sure that everything is functioning. We'll check that the key switch turns everything on. We'll make sure there are no shorts or anything. Hopefully there'll be no sparks. We'll check all the voltages. And then we can put the controller in place here and then set up all of the wires and connectors and all of the wiring so that, for these wires over here. Then we can place this frame, then we can put the fork on and the swing arm on, and then we can finally put this together as a bike. All right, so now we're ready to do this bench test. I have a power supply that's running 84 volts, and that's going directly to the main connector. So then when I turn the key switch, everything should activate and we shouldn't see any sparks. Okay, nice. We have the LCD screen working, and then the tail running light is working. This is the brake light, so yeah, when I click this, the brake light activates. Some of the pins for the LCD screen are not connected. This is that display that requires 12 volts, and you get some icons here based on what you're doing. And then also when you click the brake light, there should be an icon there, but I don't have those connected at the moment. This is the switch for the headlight. So when we flip this, you can see the headlight turns on. And then this switch is for the contactor. So we should hear the contactor close when we hit this. All right, so there it goes. And that's it. So that's the entire system. See that everything is working. So the next step would be to put the controller in place and then make all of the connections between the electronics and all the controller signals. Then we're gonna wrap these wires. We're gonna do something with the pass-throughs over here, make sure everything is well put together. And then we can flip this over and put the battery in place and then put the bike together. So now I have the controller mocked up over here. And for the harness on the controller side, there are a few things that I like to do. First of all, a lot of these connectors are pretty bulky. This one for the throttle, it's this large type of connector. This one's the same over here. And then for the orange lead, this is the on-off switch for the controller. This purple one is the 12-volt brake lead. I already snipped off the connectors because the connectors were these sorts of connectors. It's just a single wire. But this connector is, very bulky just for a single wire. So when you put these into the frame, there's limited space in there. So there's no reason to use these large bulky connectors. Probably the only one that's worth keeping is this Hall sensor connector, even though it's pretty bulky, because this is kind of a standard connector that is also on the motor side. So if you change this, you'd have to change the motor one as well. So really, this is the only one that's kind of an issue. And it is kind of an issue because it doesn't fit through to the other side of the frame. So you have to take this connector off anyway, pass the wires through, and then put the connector back on the other side. So that's already enough of a pain. But for the rest of them, I like to remove them and replace them with my own. These are just single wires. They can be replaced with just a small type of automotive connector. And then these connectors for the throttle, there's a main throttle over here, and there's another connector that's just like it for the regen braking throttle. So there's two connectors like this. But the throttles typically come with this sort of DuPont connector, which is much lower profile and better. So we're gonna swap these out for these DuPont connectors. And a lot of times, based on the way the throttle is set up, like black is ground, red is the 5-volt power to the throttle, and then the signal is on the white lead. So there's no guarantee that these are going to be set up. So this one, for instance, it's set up differently. You have ground power, and then the signal is on the middle lead. So you have to take off the connector and move it around anyway. So might as well put on a smaller profile connector like this. Now I have the connector swapped on the controller harness, and I replaced the larger connectors for the throttle. This is the throttle for the bike, just a DuPont connector, lower profile. Same thing for the e-brake throttle, just a smaller DuPont connector. I cut the connectors for the low brake here because I'm not going to be using it. I'm going to be using the high brake instead, which is this purple one. And here I just placed one of these connectors. Then this orange line is the on-off switch for the controller, which takes high voltage. So just gave it a nice solid waterproof connector here, just something for extra safety. The hall sensor connector I had to take off because it's too big to fit in those holes. So I'm gonna have to pass it through like this and then put the connector back on. Kind of a pain, but that's okay. This is reverse. I'm not gonna be using a reverse for this bike, so I just snipped that one as well. And I left the connector here for the 3-speed switch. And this is for the display. So there you have it. The controller is ready to go, so we can place it on the bike, pass that harness through, and then we can figure out what the length is for all of the wiring that attaches here. All right, now that we have everything connected, I've placed the controller over here on the frame and also passed the phase wires through this pass-through back here. So I have in a separate video where I disconnect these from the hub motor so that you kind of have this adapter wire that goes to a junction box on the swing arm to connect to the hub motor. So this way you can prepare the frame completely without having to actually connect the hub motor. So this comes out of here, goes through the pass-through, that runs all the way down here. And then there's another pass-through here for the battery wires and the phase wires that come through on this side, and they just connect to the controller right there. Then the controller wiring harness will come through here along with all of the wires for the accessories. And that's going to be a thick chunk of wires. I don't know if I'll be able to fit it into a pass-through actually because of the connectors, but we'll see, come up with some solution there. But that's basically ready to go. I've got the covers here for all of these elements. Everything is connected as before. And now we're ready to mock up the battery pack. Okay, next we're gonna place the battery pack into the frame just to check the fitment. And you can see here I have these straps. These will go around the battery pack just to secure it down. And I also have some standoffs and some aluminum sheets to place around the battery pack because this battery pack doesn't have a aluminum case. It's mainly just wrapped in a few layers of heat shrink. So it's protected electrically, but it doesn't have a structural component to it. So what I'm doing instead is placing some aluminum sheets around the battery pack inside the frame to give it that structural integrity. Okay, so you see the phase wires are running through this pass-through along the bottom of the frame. So of course the battery pack will need to be raised a little bit in order to allow these phase wires to run. The solution I came up with are some 3D printed standoffs. This one has an R on the bottom indicating that it's the one at the rear. And the reason for this is because you have these side panels and they're just a little bit more narrow than the part here. So this is about 2 millimeters more narrow than the other ones. And that goes right there. But before we do that, I also have this sheet of foam that I cut, and that will go on the floor of the frame to just prevent any banging or knocking, and really to just kind of even things out on the floor because there are some screws that are welded to the bottom. It's not exactly even, so this will kind of give it a nice flat surface and also prevent extra noise. So then this piece goes here, and then the rest of the pieces they slot together. Also, they have these standoffs over here to support the weight, and then the phase wires will run through this portion here. So that will attach right there. Then there is another piece which attaches right here. And then there's a portion for the front. This is a little bit more narrow, or it's not as long, and it doesn't have the standoffs over here. It doesn't really need to support the weight. The idea is that I will put some of these connectors under here to just kind of keep them out of the way. But for now, we're just gonna place it right here. Like that. So that creates the standoff platform for the battery pack. Then we'll add another layer of foam, and then a piece of aluminum sheet. So the reason for this is that the battery pack actually needs to slide back and forth just a little bit when you're placing it into the frame. And this also creates like a nice solid platform to place the battery pack. If I were to just use the foam, when I slide it back, it'd be really difficult and it would probably bunch the foam up. So it needs this. I'll show you why it actually needs to slide back when you're putting it in place. There is another piece that I have back here. So this is just another piece of foam and another piece of aluminum. So that goes right there. And then we have another piece of aluminum that just slides in like this. All right, now we're ready to put this battery pack into the frame. And it's a little bit tricky because this thing is a bit too big for this frame, but it's not too difficult to put it in place. You just have to kind of maneuver it, make sure that opposite corner doesn't snag on the back of the frame, and somehow it's actually possible to maneuver it into place. So once it's in the frame, the first thing you need to do is push the battery pack all the way forward. And the reason for that is because I have these aluminum sheets that are going to go between the battery pack and the frame right here. You kind of just shove them in place, and this will basically keep the battery pack from moving side to side and also distribute the force over this area. So they're secured by the bottom of the frame here and the back of the frame right there, and then these straps will go over them. So this will provide kind of a nice flat area to distribute the force of the battery pack. And once these are in place, then we would slide the battery pack back along these metal sheets, and it basically just snugs right into that rear corner. So that's the reason that we need to be able to slide the battery pack back and forth. So let's do this other side first. So that side is good to go. Now the other side is a little bit more tricky because you've taken up some room with that other aluminum sheet. So now the battery pack is shifted a little bit this way, and that's fine. But it's definitely possible to shove this in here as well. So now that we have the side panels in place, we can take the battery pack and just slide it all the way flush against the rear of the frame. And it does take a little bit of force, but not too much. So it should be fine. And then of course the force from the corners here, whereas otherwise it would be directly pressing into the battery pack, is distributed amongst the area of these sheets. So, and then of course it wedges the sheets into place. So then everything is nice and snug. And then finally we can take these straps and strap everything down. And all that needs to be done is to make the connection here, and then we'll be live. But we're not going to do that right now. This is just a mock-up. All right, now we've got the battery back out, and it's time to finally assemble this as a bicycle. Okay, now we are at the point where we're ready to make the final connections to the accessories and the controller wiring harness. I have all of the connectors on here. The Hall sensor connectors are back on. The connectors for the LCD screen are on, and everything is pretty much ready to be connected. This is the throttle. This is the throttle for the variable regen on this side. I've got these labeled. This is the headlight power. So this goes directly to the headlight. Then this is the contactor switch. This is the switch for the headlight. This is the 3-speed switch. There's 2 of them, one for the controller harness and then one for the LCD screen, which will display what speed you're on. Of course, this is the Hall sensor coming off the hub motor harness. Then these wires here are for the LCD screen. This is to power the LCD screen, and that's going to be coming from here. This is ground, and then the green one is high voltage. Then these blue wires, this one is for the brake, and I don't actually have a way to connect the mechanical brake here because these are hydraulic brakes. I don't have a way to connect the switch, so for now we're going to leave those unconnected. Then this black one is the 12-volt positive line. I don't know why they made it black on the LCD screen, but it takes 12 volts positive, and that turns on this lower display over here. I don't know why it needs a separate power source, but it does. Then this yellow wire with this type of connector connects to the Hall meter on the controller harness. So this sends the speed signal to the LCD screen. And this is the 3-speed switch, connects there. So that's the LCD screen. Then this is the controller harness. Here we have the 12-volt positive brake, which again, I have no way to activate at the moment, but 12 volts would be applied here for the brake. This is the meter, the Hall meter for the LCD screen speed. The yellow one here that we're not using is the low voltage brake. I forgot what the white one is. Then this is the regular throttle. It goes here. And then there's another DuPont connector on the harness. This is for the variable regen. Of course, this is the other side of the Hall sensor. And this is 3-speed switch. So that is the controller harness. And then finally, we have the inputs. So also on the controller harness, this is the on-off switch, the high power on-off switch, high voltage on-off switch for the controller. Then over here, this will be the positive 12-volt input for the LCD screen that I showed earlier. And this is the ground and high voltage to power the LCD screen. Then this will connect, the screen one is also high voltage. This will connect to the controller to power the controller, or actually it's the switch to turn it on. It doesn't power it, it's just a switch. And these 2 blue wires are both brakes. So when you activate, if there's a switch connected to the brake up there, then these 2 wires will send that 12-volt signal. And of course, then we have it up here. This is the headlight power source. This is the headlight switch. Then this is going to be the tail light, including the brake light. And this should be the switch for the brakes, which, like I said, I don't have. And of course, the brake light is here. And it's just coming out right there. So we have the actual running light and brake light, and this is the switch. And those are all of the connectors. Okay, so now I've got all the connections made inside the frame. It's not exactly neat and tidy, but this is just to do a quick test with everything connected, make sure that everything is still working, there are no shorts or no issues. So I've got my power supply connected here once again. Let's just turn that on. Now we have the power supply running. It's providing 84 volts, and I don't see any sparks or smoke, so that's a good sign. So now when I turn the key switch on the other side, we have power. So you can see the LCD screen working. This is the 12-volt display that I was referring to earlier that's powered by that separate 12-volt signal. Right now it's indicating that we are in eco mode, low power, and that is in fact true. The switch is on number 1, so when I turn this to 2, we're in normal power mode, and then 3 is sport mode. So that switch is working. Then this switch should give us headlights. Nice. Then we have the running light here, that's working, and I still haven't come up with a solution for a brake switch, so I'm still using this temporary switch for the brakes. And when I press the switch, you can see that there's an indicator light that activates in the LCD screen in case you don't know you're braking, but you have a light there as well. And then finally, this switch should be the contactor. So when I press this, you should hear the contactor close. And that sounds like it's working. And then also we see that the USB port is activated as well. So that's great. We have the entire system working and everything is connected. All right, now I have some of the wiring cleaned up over here. You can see the wiring running along to the top over there. And the way I have the wiring set up on the bottom is I can shove it underneath these standoffs. That's kind of the idea. So the phase cables run through this third section, then I have some stuff that I can place in the middle, and the rest of them are placed underneath there. I just need to redo it a little bit because I need it to be flush, and this one still is a little bulky here, so it's not able to go down all the way. So I'll have to just fold them a little bit better, and then all of these will be in place like that. And the only connector that doesn't fit is the one for the Hall sensor. So that's just gonna dangle out here. Then this is actually the hydraulic cable for the rear brake. I have it running through the frame and then coming out here, and that's going to the brake. Pretty much done with the inside of the frame here, and I'll just need to wrap and clean up these wires here, make sure that they're long enough and everything, which I probably should have done before, but I think they should be fine. And then I will finally be able to put this battery in place and then finally mount the wheels. All right, now I have all of the wires in place and underneath the standoffs over here. I just have some clamps holding it down so they don't shift while I do this stuff. But I've installed the hub motor, and that was pretty easy since I have the phase wires disconnected. I have another video where I basically cut them and then put them on connectors over here. So this way the phase wires can stay in the frame, and then the wheel and the phase wires that are attached to the motor can be easily removed. So if you get flat or something like that, you could remove this hub motor wheel just as easily as you could a regular tire. So I have that set up. They're all connected down here. I'm just using this little junction box for the terminal lugs, and then this is a waterproof connector that I'm using for the Hall sensors. So now I have everything connected. This is the battery here. I have it connected using some jumper wires. For this test, we don't really need any high current, so these jumper wires should be fine. So now we can actually do the first test with the hub motor in place. So turn the key switch. We can see that the display is working. Lights are working. And now we'll close the contactor. And then when I turn the throttle, this hub motor should turn. Nice. Sounds good. Then you have right now it's in normal mode. This is economy, sport, but that's pretty much it. Oh, and the speedometer works. Right now it's in kilometers per hour, but you can actually calibrate this LCD screen to do miles per hour. So that's cool. So now I just need to put this battery in the frame, which would be a little tricky given that it's leaning backwards, as I mentioned before. So figure out how to do that, And then once the battery is in place, we'll put the front wheel in place. And then from there, it's really just tightening everything and getting it calibrated and aligned. And then we're gonna take it for a test ride. Here's the bike with the battery pack in place. Everything is now ready to go. Do one more test. Here's the LCD display. You can turn the contactor on and the wheel is now spinning. I've got everything calibrated in the app as well. Here is the LCD display. It's currently in kilometers per hour, but I'm going to switch it to miles per hour. And then I also have my regen braking right there. All right, and now we have the bike fully assembled. I've got the side panels on. I gave it a good cleaning. This thing is ready to ride. I think it looks great. The one thing I don't have on is the chain at the moment. I didn't put that on. Otherwise, this thing is ready to ride, so let's take it on the road and see what it can do.
Okay, here we are riding the Stealth Bomber e-bike. I've got it on normal mode right now, and I have the speed limit on normal mode set to about 35 or 40 miles an hour. So that's what it should get us. But before we do that, let's put it into eco mode. Alright, so right now we're in eco mode, and the speed limit in eco mode is currently set to 20 miles an hour. You can do it via the app as a percentage of the total speed. So right now I have full throttle open and I'm going about 22 miles per hour and using about 15 amps. So let's put it into normal mode. So normal has a speed limit set to 40 miles per hour. So it definitely gets some good pull. I think we hit about 100 amps there. And now we are running about 40 amps and limited at 40 miles per hour. So it's definitely a smooth ride, feels fun. I also have variable regen braking set up, so that's on the thumb throttle on the left side. So that when I hit that thumb throttle, the motor will use the momentum of the bike to generate electricity and recharge the battery. And the more I engage the throttle, the more current I'll get. I have the current limit set to 100 amps, but I'm not sure if that's battery current or phase current. But we can definitely give that a shot. So that's the variable regen. I am slowing down pretty drastically. And that was only with a little bit of input. So I think I saw about 20 amps. So right now I'm still in normal mode. Going about 35 miles an hour, so that's the regen. I'm going to hit it pretty much all the way. And that's some pretty substantial regen braking. I didn't see what the current there was. Yeah, I think that was about negative 40 amps that I hit for regen, so that's pretty cool. Alright, so I'm feeling pretty good about this bike at the moment, so let's throw it into sport mode. So right now I have the bike in sport mode. The speedometer, by the way, is in miles per hour. So if I accelerate, get a nice pull from that position, and then now we're doing about 45 and using my regen to slow down. I haven't even really used the mechanical brake so far. Let's go down this way a little bit. Alright, so before I do a full acceleration test from a dead stop, let's just try a fully open throttle in sport mode from about 20 miles an hour. That's pretty good. We got up to 50 there. Pretty modest pull. Much current. I think we hit about 175 amps there, which is cool. right, so that was braking with fully regen, and then at the very end I added in the mechanical brakes. All right, so let's do an acceleration test from a dead stop in sport mode. So right now I have it in sport mode. I'm just going to open up the throttle all the way. All right, and let's hit it. All right, so that was fun. I think we hit about 55 miles an hour there. But let's go find some more clear road, and then we'll test the top speed. All right, so here I'm going to open it up all the way and see where we can get in terms of top speed. Just short of 60 miles an hour, 59 miles an hour, I guess, is the top speed. There's also an option to adjust the flux weakening. So maybe if you play with that, maybe you can squeeze out another mile an hour. And I was braking with regen only, so I have barely used the mechanical brakes at all here, so that's pretty cool.
And that is the Stealth Bomber e-bike. Guys, let me know if you like this video in the comments. If you have any questions and you're building your own, please leave them below. Also, if you like this kind of content, please subscribe, hit that notification bell, and like. And I'm going to be posting a lot more videos soon, so see you later.